This podcast is sponsored by the Building Performance Workshop, helping pros make more money doing better work for happier clients with advanced NBPI trainings and our new book, Home Performance Diagnostics. More at buildingperformanceworkshop.com. Enjoy. Welcome to the Building Performance Podcast from Green Dream Group in Chicago. I'm Corbett Lunsford. Today we're talking about trends in high-performance building and retrofits from the ventilation angle, again with Don Stevens, who is the National Research and Development Manager of Panasonic Eco-Solutions North America. Don, thank you so much for being on the program again.
Thank you for inviting me back.
So last time we talked about the ASHRAE 62 1989 standards and kind of just the evolution of the standards into 62.2. Now that 62.2 is being adopted by many states as a ventilation requirement as part of the IECC 2012, which incidentally is code in Illinois, we're having to deal with what the subtleties of this are. So first thing I'd like to ask you is, what is the essence of the 62.2 spec, specifically in the fan ventilation requirement versus the total ventilation requirement?
Okay, the calculation method that has been used in ASHRAE 62.2 since we started developing it in the late 90s has been based on 7.5 CFM per person plus 1 CFM per 100 square feet. And so that was the sizing number for the whole building or the whole house, basically continuous ventilation approach. That, from the beginning, has assumed a leakiness of the building of natural leakage of about 2 CFM per 100 square feet. So the total ventilation was the mechanical rate plus that default assumed leakage. So the number that was required in the mechanical portion plus the assumed default number basically got you up to pretty close to what the 6289 number was, the 15 CFM per person or 0.35 air changes per hour, whichever was greater. So this has been the number now for about 14 or 15 years that we've used, the 7.5 plus 1 per 100, assuming 2 people in the master bedroom. A change that is coming, that's been approved as addenda, has been published as addenda to the 2010, and that will be included in the 2013 when it's published this summer, will increase that rate to assume no default, but then you can deduct the amount of measured leakiness based on a blower test using new weather data that's been developed for that addendum to 622.
Interesting. And what was that original assumed leakage of 2 CFM per 100 square feet? What was that based on?
That was based on thousands and thousands of blower tests across the country in data that had been collected by Lawrence Berkeley National Laboratory over the previous 10 or 15 years of how houses were on a tightness level based on a database that LBL developed actually starting in the 80s, and it tracked thousands and thousands of blower results. Consequently, it gave a reasonable assumption, and we all know what assuming something does, but it was a reasonable assumption for an average amount of leakiness anywhere in the country. And it would be higher where there's bigger driving forces and lower where there were lower driving forces. But when you're writing a national standard, you have to make some assumptions. So that was the assumed amount of leakiness. What's happened over the last essentially 15 years is that we started building a lot tighter because of energy concerns. We've learned a lot more in actually how to do that well and do it in a workmanlike manner, not as a specialty trade, but as a matter of how to build. So the houses have been getting much, much tighter than they were historically. As a consequence, as you stated, the 2012 International Energy Conservation Code and International Residential Code require blower door testing of the house, require that it be built to 5 air changes per hour at 50 Pascal level of tightness in the very temperate climates and 3 ACH 50 in most of the climate zones, including where you are.
We actually have an addendum to make it 5. They made it a little easier. But we will get to 3. Now, as I understand it, and obviously, since I'm a HERS rater, I work on new construction and I obviously help with this process. How did ASHRAE see the process actually working out when you have the fan ventilation method where you just calculate 7.5 CFM per person plus 1 per 100 square feet? Or you do a blower door test and now you get into the math. Like this is where there's tons and tons of math then going thereon. I would assume that most people would stick with the 7.5 CFM per person plus. Uh, is there an accidental scenario where a builder might build much tighter than they were intending to, and then only be supplying 1 CFM per 100 square feet instead of the 3 that you actually would assume would be there?
That can certainly happen. As you know, the vagaries of making a tight house are in the details. If it's a rectangular box, it's pretty straightforward. If it is a house with cathedral ceilings and dormers and lots of corners and lots of places where it's hard to air seal, it's much harder to make it tight. So unless you blower door test it, you really don't know how tight it is. So will there be places where people will not put enough in? Yes, that's been the concern. That's why this change is coming for 622 to actually say you got to build it tight, and then after you blower door test it, which, as you know, you can't do until you're done, then you can determine what the ventilation rate needs to be, the mechanical rate, after you've deducted what your calculated leakage is.
And that would be where one of your Panasonic adjustable rate fans would come in handy.
Well, yeah, that's part of what I designed into those is the ability to just change the speed right so you could size it for the amount of mechanical ventilation you need.
Now, I'm curious on my own project. I have a project where we came in late in the process and we said, oh, you need to meet ventilation. We need mechanical ventilation. And here they said there's no room for a separate ducted system, and there is no return plenum because the return is straight through the wall. So the only thing we could do would be exhaust fan ventilation. So we're kind of hoping for a slightly leaky envelope. It needs to be tighter than code and to meet Energy Star, but it still needs to be leaky enough to pull air in through the gaps and cracks in the building envelope. How have you seen that play out practical application-wise across the country?
Well, from an energy standpoint, exhaust ventilation works reasonably well in all climates. The issue that comes up is you don't know where those leaks are if you're not planning for them. So I'm kind of a proponent of putting in fresh air inlets if you're going to go exhaust only, so that you have some areas where you know that air is going to be moving in or out of the shell, but you know where it is, and maybe you can filter it, or using matching up a supply fan with the exhaust fan, so you get not only balanced flow, again, so you know where the air is coming from. What we've been finding over the last year or two is that we're now getting some people who are extremely good at building tight buildings, and they're getting the building tight enough that without overt openings, that the exhaust fan is capable of pulling the house fairly negative. And that's not an issue typically when you don't have open combustion devices. But if you have devices that require air for combustion, then you get into the concern about backdrafting. And so we're beginning to see people say, gee, we can't, we're pulling this building down to a tenth of an inch negative, 25 Pascal negative, with the whole house fan running. And the reality is that they have made it very tight, makes it tougher for the air to get in, and consequently creates a bigger delta P across the shell.
There is an exception built into ASHRAE 62.2 that says you don't need ventilation if. Could you go over that brief exception?
Well, that exception basically is to account for, summer cottages or other places that are just used a little bit, and the number that's used is 10% of the hours of the year. So that if it's a summer house or it's a winter cabin and it's only used occasionally, i.e. less than 10% a year, then meeting ASHRAE 62 can be exempted based on what the standard says.
Interesting. And is that based on research or is it based on an assumption?
It's pretty much based on an assumption that's a reasonable accommodation for occasional use facilities, that you don't need continuous ventilation in a place that nobody's going to be at for 8 months of the year or something.
Mm-hmm.
As a,
Mm-hmm.
kind of, it's just kind of a logic sort of thing. Is it research? No, it's just an assumption to have a reasonable man response.
Gotcha. Okay. And then for multifamily, additionally, there is an actual bonus for ventilation that you would need. And how did that get calculated?
What's been found over the last 5 years or so is that the research has continued on how to air seal multifamily buildings and to look at where the ventilation air is coming from. As a consequence, the Addenda J to the 2010 622 edition goes to this 7.5 per person plus 3 CFM per 100 for multifamily, but it specifically doesn't allow any deduct for leakiness because the experience has been that these buildings are very tight and that the air they get isn't outside air anyway. It's coming from the neighbor. Good, bad, or ugly, it's coming from the neighbor's unit. And air is leaking in somewhere, but it's often moving from unit to unit, and it's not really fresh air. So as a consequence, this addendum to 62-2010 and what will be as part of the published 2013, and it's an item that's part of the California standard that was adopted by the California Energy Code, multifamily will have to put in this larger amount. The ending out is typically 25 to 50% more ventilation. It's not a huge number compared to what otherwise they would have done under the current assumptions.
And what's coming down the pike with the 2013, if you could share anything about 62.2 from 2013?
Probably the biggest change is this issue of having to account for this larger amount of ventilation. And then for single family, you can deduct based on leakiness. But part of that addendum has all new weather data for calculating that annual average leakiness. And that's not data any of us will use directly. Typically, it'll be used by the blower manufacturers to update their software so that they're using what's now like 1,300 data points for weather around the country to determine what the weather factors are when they calculate how leaky a place will be, as compared to the data that was used in ASHRAE 136, which used to be the source for that information, but it only had a couple of hundred sites. So it's a lot more accurate data set, and it actually shows, according to Dr. Ian Walker at LBL, it shows that on average most of the weather sites are a degree or two warmer than they were in the old data set. To essentially convert, or to be able to determine what the CFM50 impact will be when you calculate down to get to what the natural air leakage would be. Mm-hmm. So if you have a CFM50 or an ACH50 set of data, all that's doing is showing what the fan measured at the time the test was done, the single point test. But to use that, then it has to be converted to what the average annual prediction would be, and that's a function of the height of the building and the weather and the wind and the local site conditions. So a two-story house has more stack effect, for instance, than a one-story. And a house that's in Minnesota has a higher stack and wind effect than one in California because there's not as much temperature differential. So that ends up being a number that's used in that calculation that, in essence, is divided into the ACH50 or CFM50 number to get down to what the annual average prediction is.
And do you predict the need for more sophisticated blower door testing training across the country in order to meet this new standard?
I don't think it'll take a lot more training. I think it'll mean people need to be looking at the software that they're using, and it means that the manufacturers like Retrotech and Minneapolis Blower Door will have to update their software to reflect the new weather data.
Great. Well, thank you so much for being on the program, Don.
Sure.
Don Stevens is the National Research and Development Manager with Panasonic Eco-Solutions North America, and he's on the board of ASHRAE. Thank you very much for listening. You've been listening to the Building Performance Workshop from Green Dream Group in Chicago. I'm Corbett Lunsford. Tune in next time.